Okay, so we've got the May meetup. Damien was going to talk about porting his keyboard to using MicroPython, but he's had some sick kids and his keyboard is in bits and nothing's working. So he's apologized, but has had to pull out. So we'll probably push that out till next month. So yeah, apologies. And Damien, I hope things are getting okay. And yes, porting does mean breaking in this case. Thanks, Andy. It's absolutely true. So let's get through this. We've got a bit of things to discuss. So it's the 11th birthday of MicroPython in the past month. April 29th is the official birthday. I think that's conception if we're getting technical, but I think the first commit was somewhere within a year after that. But that is here forever known as the birthday of MicroPython. So happy 11th birthday, MicroPython. The release hasn't gone out the door yet. So please stay tuned. Again, I think sick kids might have an effect here. And we've had a lot of feature creep, but some of that was due to PyCon, which we'll cover in a moment. Why is and getting features in for the PyScript folks who were presenting at PyCon. But yeah, it's very close now. There's only 1 or 2 tickets left in the milestone. So, and I think they've mostly been done. Arduino Alvik we've talked about a couple of months ago when it was announced, but it has started getting to people's hands. This is the device that's running an Arduino Nano something or other. So Carlos, I'll come back to that in a sec. Sorry. Yeah, there's an Arduino microcontroller on the top there. You can see that. It's got a couple of motors for the wheels, some other input devices, accelerometer, a bunch of stuff. They're about 140 US, which for me seemed expensive, but actually when you look at it and compared to other things in the space, it's pretty good for like a classroom sort of kit. And people say it's really quite polished and pretty neat, so it looks good. It was also like they're doing the right thing. Like there's a MicroPython repository which is MIP installable, which is pretty cool. They've also packaged the firmware to go grab the appropriate MicroPython firmware and put that on the device first. So yeah, it's looking really good. Alex Glow, who's the person from Hackster.io, she does some really good unboxing videos. This one was definitely no exception. It was really good hearing her sort of excitedly pull it apart and this is so cool. It was really good. PyCon, well, I say was on, but it actually wraps up officially, I think, tomorrow or in a couple of days in Pittsburgh in the US. It's always a really good source of Python news in general. There's a couple of MicroPython specific, well, there's one CircuitPython, one MicroPython specific session. And there was also 3 PyScript sessions. Now, kind of took me by surprise until I started looking at what the PyScript folks are doing. It's actually really quite impressive. So I'm looking forward to seeing all of these videos. Actually, they haven't been released yet. They usually take a little while to release it. Last year was almost 3 months, so they might take a little while. So stay tuned. The first one was by Juliana, and she was talking about using BBC Microbit, and I believe it was a tutorial session. But I had a look at her slides, which I'll share at some point. They looked great. Yeah, looking forward to trying to drag Juliana to Melbourne for PyCon AU. Don't know if it'll happen, but it's a nice thought. She's been quite heavily involved in the microbit for a while. Jeff Epler works for Adafruit, does some great stuff with CircuitPython. He was talking about interface into old retro computer stuff. So I think a lot of people will be interested in that too. The PyScript ones, there was a couple of documentation talks, and there was another one based on like 3D experiences with WebGL with PyScript from Lukas Langer, who's a core Python dev. These are all kind of hinting at the kind of interesting stuff that you can do with PyScript these days. And it's moving really quick. In fact, if you go to PyScript.net now, I think we can probably do this. Hopefully nothing falls apart. This is their main site for doing documentation and whatnot. And this is actually a live MicroPython prompt that they're automating so that there's some stuff that happens there, and then it's literally live, so you can do whatever you want, except the keyboard. So this is actually It does use WASM, yeah. And so there's a fair bit going on here. We've talked a little bit about PyScript, but they can use either the full CPython compilation or MicroPython, both compiled down to WASM. And I guess the thing that's really happened in the last month or two is they've got really good DOM access from within both environments now. So you can actually interact with the DOM and do actual web development in using either CPython or MicroPython now. And this is getting particularly exciting for MicroPython because it's much more lightweight. So we've already seen people use it to do web development stuff, which is not an area that we expected to see MicroPython sort of perform well in. But yeah, it turns out it's actually really usable. And we've got a couple of other things that are adjacent to that. We've got Andreas, who I believe works at Anaconda. I don't know if we'll get the sound here, but I don't know if you guys can hear that online. But the important thing is to see that thing's blinking, right? Okay, that's not, that's, it doesn't look much on the surface, but what's going on here is that you've got MicroPython running in the browser, making a web serial connection to a device running MicroPython, which he's holding in his hand, and injecting MicroPython commands to it. That's a pretty compelling little demo, I think. Yeah, I thought that was cool. So. Andreas has released all that code as well. So MicroREPL is that web serial code that's all JavaScript. I think you might have used TypeScript, I can't remember, to make that connection and to inject those commands. But people are legitimately already using this. So PySheets is a commercial application which was released in the last couple of weeks. It's meant to be like a spreadsheet UI for Python. So you can do Python in a browser in a spreadsheet. And you can also do things like render matplotlib. You can use Seaborn. There's a whole bunch of things that you can actually use all those data sciencey things, which is part of the attraction of using Python in the browser. But interestingly, the one of the creators, there was two founders of this project. One of them was on this Hacker News announcement page, and he was talking about how he's actually using both backends, which PyScript does allow. And he's using MicroPython to get the speedy sort of load time and render the UI, and using the full-blown CPython backend to do all of the data sciencey stuff. So this is a commercial product. I can't recall what the pricing's like, but it's pretty amazed to see it moving as quick as it is. Yeah, pretty cool. Sorry, I ignored some stuff online. Carlos. Damien's keyboard. So fun fact for our esteemed creator of MicroPython, he uses a custom-made keyboard. He might have got it from I can't remember if it's a bought one he's put together himself, but there's no keys written on his keyboard. It's completely blank. And just to make things spicy, he's only types in Dvorak. So if you go to Damien's keyboard, it's like you're speaking another language as soon as you type into it, because you have like, I don't know about you guys, but I don't know Dvorak off the top of my head. And without the letters on the keys, it makes it really hard to type. So, yeah. So, but I'm sure it's a really good test bed for the USB device system that he's putting together. So, yeah. Yes, and keyboards are a bit of an addiction, or can be. Right, so MicroPython in the browser is apparently already here. I thought that was kind of interesting. That kind of snuck up on me. I didn't expect to be able to say that. My new hardware, I've got an H2. It's one of the Espressif boards. The H2, like especially for churning out these chips at the moment. The H2 is their non-Wi-Fi version with it's aimed to be very cheap, but also supports Matter. That's kind of their push for it. I got this because we've been looking at the C6, which is a different one, which I'll talk about in a little while, and it should actually leverage some of the work we've done for the C6 port. So I think we'll be able to get that running pretty quickly. Not the Matter side of it. That is a whole nother kettle of fish. Really difficult to see how we're going to get Matter support with MicroPython. It's a challenging thing because Matter kind of wants to own the whole hardware. So need to figure out how that's going to fit in. But yeah. And yeah, Andrew, I think PySheets is a pretty good example of the PyScript. I think I suspect that the PyScript folks might have been working with the guys to make sure they provide all the features they needed. I'm hoping to have a PyScript demo maybe next month. We'll see how time goes. But I have seen how you can import a module in MicroPython which allows you to interact with the DOM, and it's pretty cool, pretty compelling. Anyway, so that's the H2. Went back and forth a lot here. I'll have to disconnect. So for those that haven't seen it, the bling, which is extremely bright, is Sion's board. Sion's the unexpected maker, for those that don't know Sion Rosenblum. I've gotten my hands on the bling board and his tiny C6 module because I'm trying to get MicroPython running on them. We've got MicroPython on the tiny C6. Haven't started with the bling yet, but it is very cool. Lots and lots of LEDs, and he's done a great job sort of implementing various patterns on it out of the box. It's running, I want to say Arduino, but I don't know. Yeah, but so many little LEDs, 380 of them, there's 320 of them in a 40x8 pattern. That thing's got 8 mega flash and 2 mega RAM. Got a few buttons on the sides. It's also got I2S microphone and amp, so hence that's where it's getting all the audio information from. But we can use that in MicroPython, so be curious to see what kind of throughput we can get with it. Not as much as you like. He does go into detail on it. These are super efficient, and they're ridiculously bright. Sorry?
It's very hot.
Yeah, it does. If you're putting white on, you'll draw a fair bit. But it's got a 700 milliamp regulator, and I think he's done it so that when it's at 80%, it can do a constant, something in that order. But don't quote me on that. Yeah, it's a pretty nice little board. The C6 is a lot less impressive, but really useful. That's one of his in the tiny range. There's a few of them now. Started with the tiny Pico, which is the ESP32. There's a few of them. This is the latest one, or maybe it's not the latest one anymore. I don't know. But yeah, C6. The C6 is pretty compelling. We'll probably go into this in a little bit more detail later, but it's a RISC-V core. It's at 160 meg. It's also got like a low power RISC-V core as well. But it's got Wi-Fi and it's got BLE. They're cheap as chips. They're really quite a neat sort of sweet spot in the ESP range. Yeah, I like them a lot, actually. Only 180C though. We've also had a PR from NXP. I can't remember the range. It's 947 is this particular one, but this is the range of general purpose NXP Cortex M4s, sorry, M33s. And they're pretty neat chip. I bought this mostly so I can help with the PR and try to take the load off Damien and Jim on testing. But yeah, one of the things I noticed was there's up to 124 GPIOs in this thing. It's got DSP and neural net acceleration. CAN and Ethernet comes built in. And it's got some really good redundancy features. Like, you can set up the RAM so it's ECC RAM. And it's got a couple of meg of flash. You can also put that in dual bank, so you have redundant flash as well. It's a pretty neat little board. Pretty neat little micro, and a pretty capable board. Yes, Joz, there is a C6 branch. I'll come to that in a sec. And yeah, thanks, Andrew. Chris is really active. There's a few of them that are pretty active as well. It's great. PyScript's moving swiftly. Sorry to jump back and forth here on this. Yeah. In hardware news, I meant to talk about this last month or the month before, but this was just a nuts board that I saw. It was apparently a collaboration between RT Thread, who do like RTOS, and Renesas. And so it's powered by the Renesas. We talked about this micro when it was announced, but it's the 480 meg M85. So it's probably one of the more powerful chips that have come out. M85, it's the first M85 that sort of hit the market. And I don't know how RT Thread got involved with doing this, but they've put together this board which has bucket loads of flash and RAM, 2 meg on board, 1 meg RAM, 8 meg flash, and then the 32 meg of SRAM as well. And they've obviously geared it up so that you can do a lot of camera or vision work. But they've already got a port to OpenMV. They've got a bunch of other examples using LVGL. There's also a GPU on this thing. yeah, you got MIPI output, like it's a bit of a beast. These boards are about $53, or with a camera and an LCD on the back, they're 60 odd bucks from the official shops on AliExpress. So I haven't bitten the bullet to get one yet because there's still like some of the documentation still trying to ease, still trying to figure out a few bits and pieces here. But if you're looking for something powerful to play with, this looks pretty interesting. And they're doing it all open source, which is great as well. So all the examples, the SDK is all available. Yeah. The Citron Maker Uno, I think AJ or someone shared this one as well the other day, stealing my thunder. But yeah, Citron make a bunch of boards. This one's quite neat. They've just got an RP2040, which is not unusual, but having a bunch of Grove sockets, there's a Stemma QT port, and they've got like 16 LEDs as status lights on the GPIOs. And so it's kind of nice if you want to see what's going on coming out your GPIO. So as like a good starter kit, I think this is great. You can connect a whole bunch of peripherals to it pretty quickly and get moving pretty swiftly. Of course, we've got great support for RP2040. It would be easy to get MicroPython running on this. And $15, so pretty cheap board, 15 US. Yeah, Stuart, I really like the Citron stuff as well. I haven't managed to buy any myself, but I have seen them and held them, and they look like great boards. So, the Seed Studio Xiao SP32C6 was announced. I haven't got my hands on one of these yet. I think I've got all of the other Xiaos, but this one's come out. They're only $5.20 US. Same form factor that we're used to, tiny little boards. This one's really quite capable. Not much more to say, really. Get them if that spec looks good to you. These push buttons that they use them in the NRF Xiao as well. They are microscopic because, of course, that Xiao board is, it's only about 20 mil. So these boards are tiny. They work, but you've sort of got to get your thumbnail in just the right spot. Okay, Waveshare have been churning out stuff. I'll probably talk more about that next month because I've got an order coming through. But the latest one was the SP32S3 touch development board, which came with a display, touch sensitive accelerometer, gyroscope. It's basically like a little Apple Watch if you believe their marketing. But yeah, looks interesting. But the one that caught my eye was the what do they call this? The RGB LED matrix board, which is an 8x8 board. On the other side, there's an ESP32S3. Yeah, it's pretty neat. Andy, I know you like these little LED boards. This one's a new one with a bit more than some of the others. And for $9, you can't go too wrong. SparkFun released another Thing Plus. They've got a few of these boards. This one's based on a Renesas RA6M5. This really isn't my cup of tea, but if you're into it, we've got support for the 6M5, I think. If not, we should be able to get support for it. Renesas have been pretty good to contribute to MicroPython. Plenty of flash on this thing. There's BLE through this is the actual chip. This is a secondary chip to do BLE, which is another Renesas chip. Don't know if we've got support for that, but I think it's just an AT command set. So, yeah. Neat. Not the cheapest board, $50 US. And I know Olimex have made an ESP32 PoE board for quite some time. This is an update to that one. This is the PoE2. The Olimex had a popular PoE board using the ESP32. It seems like a fairly simple update, but it's pretty useful. It's all about power management. More or less the same specs. I think they've gotten more flash and memory. Perhaps not even sure about that. But the key thing is the board can supply 24 volts at 0.75 of an amp or 12 volts at 1.5 amps, and that's pulling it through the PoE. So it's kind of nice to have that if you want to just have a device that's just hanging off an Ethernet cable, and you want to power your other bits and pieces that are dangling off your micro. Okay, so MicroPython on the Playdate. We talked about this a little bit last week because Christian Walters done the basic work here to get MicroPython running on the Playdate. He's kept going, actually. So there's a video that's available. We can let it play, but it's only goes for a short time. But he's implemented a file system. He's implemented a file system, and you can see here that he's interacting. This is running on the simulator. He's recorded a video of the simulator, which Panic are the company who make the Playdates. They provide a simulator. But this actually runs also on the Playdate as well, and you can inject the MicroPython just the way he's doing it here with the exclamation mark message. That message can it can forward whatever string you pass to the simulator or to your device. So yeah, that runs MicroPython on the Playdate. I followed his instructions, and so I've got MicroPython running on the Playdate too, in the 1.23 version. So that's pretty cool. And so what's going on here is that he's used the embed port of MicroPython, which is kind of like it's basically the minimal port designed to be embedded in a C application. And so he's tailored that to use the C API that Panic give you to interact with the Playdate. So he's running within the Playdate's world. It's their operating system. He packages it in a format that Panic provide to run the applications on the Playdate. But then he's using some of the C APIs to render the REPL onto the display. And so you can imagine there's like Playdate graphics .print or .text or something like that to render things. So at the moment, that works really well. The next thing to do, I guess, and the thing that I think is kind of interesting is this could actually be a port of MicroPython, because there's other APIs that Panic provide to do things like manage sprites, render sprites, to play audio tracks, so on and so forth. So you could actually have all of those as a MicroPython module for this port of MicroPython. So Christian's trying to take it in a slightly different direction. Him and Deshipu, who some of you may know, Radomir, they have been working on the Pew Pew games for a long time now, which run on MicroPython and CircuitPython. And yeah, they're very simple sort of retro style games, often used for teaching and that kind of thing. So he's trying to make it easy to port those games to the Playdate running on MicroPython. But I think a little more effort, we could probably have like a general purpose sort of port here where you could have your own games running on the Playdate that actually run in MicroPython. I think that's quite possible. At the moment, Panic provide two APIs, one in C and one in Lua. We could have an alternative in MicroPython that's built on top of the C API. Yeah, Andy, I feel like I'm dubbing myself in for that port too, but we'll see how we go. MP Flash, Joss, you might want to talk about this. If you're still there, I can't see you. Oh, he's probably left his desk right at the wrong time. So the reason I was talking to Joss was because he's the one that's written this. So where is he? Maybe if I yell loudly, he'll come back. Anyway, I'll come back to MP Flash maybe when Joss is back. We'll come back to that in a sec. MicroPy Easy Fonts, Owen Carter, who I hadn't come across before. He's done a really good job of packaging a font library to render into to frame buffs. He's built a lot of this on top of Peter Hinch's work. And so yeah, this is great. He's packaged something like 90 odd fonts into his library as well, so you can import any of those fonts to use with any frame buff derived display driver. So yeah, it's a really neat package. Check it out. Joss, I was just saying, you might want to talk about MP Flash.
Sorry, popped out for coffee.
Yeah, it's good timing. I don't know if you want to talk about it, but yeah,
So what I try to do is make it simple, because I always get confused for the different boards, how to flash them. And actually, I started this as part of my MicroPython stubs and pipelines. In order to update all the stubs, I constantly need to reflash the latest software on a set of boards. And then I started to, when I had that running, of course, in experimentation, then I wanted to do some changes manually. So I started adding on a UI front end. And actually getting that just right and working for everyone on every Mac across the world and Windows and Linux machine is proving to be more of a headache than the flashing itself. I don't have support for all chips yet, because I don't have all chips, so it's hard to test. But getting some, I was, well, apart from I created this manually. Right? I created a blog post using Bing GPT, and I was amazed on the feedback. Right, so I really like that. There are still a bunch of issues that I need to work through on filtering people that have over 40 different devices or serial ports connected to their Unix systems, which is more than I have. But well, yeah, it worked well. I think it serves a purpose, because one of the things that annoys me a bit is that we get a load of people that are using, I think, Tony, just because Tony makes it simple to flash. But Tony makes a couple of other things difficult. So I hope this becomes, or this can serve a purpose to make the entry point to get a new version of MicroPython on some board a bit simpler and a bit more consistent.
So one thing is that Josh was glossing over a bit there is that it works on a number of different ports and sort of packages like the ESP tools to flash ESPs, and it knows how to use the file system to update RP2s and all that kind of stuff. So you can sort of have like a single command line interface to update any of your devices, which is quite neat.
Yeah, one thing that I still need to figure out is how to take a blank UF2 chip and get that into flash mode. So there's a CLI tool for the RP 2040s, but I'm not sure. Right, SAMD, for instance, it also uses it, but if there's no software running on it, then how do I get it into flash mode? So I'll probably need to step down back into, let's say, text UI land and ask for a user to actually press a button there, right? And I still need to figure out how to do that, right? Well, I know how to do that, right? But how to do it gracefully and maintainably. But yeah, it's fun, right? And I love the feedback.
Yeah, me too. Oh, thank you for that. So yeah, go use it and try it and tell Josh what works and what doesn't. There's another library contributed, the UPython Wi-Fi setup. This also looks quite nice, built on top of another one that had existed in the past, but this lets you create a device. Is there a link to it? Yes. To the MP Flash, you mean, Simon? Or to the UPython Wi-Fi setup? Yeah, let's sort that out and see. There's links to everything. So yes, if you Google that, you should get it. You can see it there. Shane Powell, UPython Wi-Fi setup. So the idea here is that you can get this running on your device that you want to connect to a Wi-Fi network, and if it's the first time you connect to your device, it'll actually start up a regular AP of its own, which you can connect to with your phone or whatever. Put in the credentials of the Wi-Fi networks that it scans and can detect, and then it will connect to those from then on. So that's the idea. I haven't used it yet, but I've got an exact scenario that I want to use this for. So yeah, I'm looking forward to trying it. Maybe tonight. This is for this thing. Yeah. It's async compatible, and he's tested it with microdot, which is ticking all the boxes that I needed. So yeah, it's great. Right. Someone asked earlier, who was it? About the Josh, you were talking about the C6 port. 11869 is the port you want to look for. Andrew started this a long time ago, actually, here at one of the meetups. And so we've been adding support for the various C6 boards that we've been collecting. At the moment, I've added Andrew did the generic C6 port. I've added the Nano C6, which is that tiny little cute board that M5 Stack started selling. It works on the O1 space. Sorry, the generic one works on the O1 space board as well as the standard Espressif C6 board. And the tiny C6 one works on Xeon's tiny C6. The only issue that I've found so far is the one I alluded to before, which was the ADCs. It's the first Espressif board that has only one ADC. So you can get into some complications if you try to initialize a second ADC. So once we fix that, I think we'll be ready to merge. But the port's quite usable now. I've used it on all three of those devices there. Wi-Fi, everything seems to be fairly robust and reliable. So yeah, I think that is a useful port. I've also been trying to backfill some of the other devices with the devices I've got here that haven't had board definitions. So can I grab the dial? So got the dial working. Actually, I should have had there's the example code now. We've got just about all the peripherals working on this now, and it has a touchscreen, display, rotary encoder on the outside. Yeah, bunch of things. The only thing we haven't got working on it is the RFID chip. You trying to make this do something?
You got any persistent code on it?
No. But thanks.
That's good.
Yeah. But yeah, Oliver and I did that in a hack session one Friday night, which was fun. I've also looked at the M5 stack DIN meter, they call this thing, which is an S3 based board. Got a board definition for that. Please go check out those. They're both on my repository or my fork at the moment, because I'm trying to figure out how best to publish these that they can be usable. Because the device drivers aren't in MicroPython lib, so we need to figure out how to publish those so they're easy to get at. I've also got one for the Seed Studio Xiao RP2040. I was using that for a work project, and so I've got a board definition for that as well now. So yeah, I guess I'm just mentioning this because it's not that hard to put together boards. So if you are persevering with like a generic board, do take a look at having a custom one. It's not terribly hard to do.
Resource.
So the next thing to mention was that I've started taking a whole bunch of notes on how to do board definitions on the various ports. I will put that up in the wiki as soon as I can. As soon as I'm happy with it, I'm not comfortable with it yet. So, right, nearly there. Sorry, folks, it's gone on for a little while tonight. Projects. There was a LiDAR library contributed by Tim McGuffin, which he also ended up writing a small application for. This is his room and him walking around inside it. But yeah, that works nicely, seems, and just looks cool. He was also talking about possibly doing a real life version of Snake, where you have to walk through your room to pick up the dots, which I thought was a creative idea. But on a more realistic side of things, he was also looking at integrating some of the SLAM libraries to do wall detection and rendering and that kind of stuff. So yeah, pretty cool. There was a car baseboard published. It's on Timby. I think that's 14 odd US. The point of this is that it's just that bare board that you can see there in the green. It's designed to host a black pill, which is a particular STM32 F411 board that in particular Waveshare sell very cheaply on AliExpress. But there's a few other suppliers for them as well. But yeah, it's designed to do remote control stuff. So there's enough headers and whatnot to drive motors and stuff like that. So yeah, quite neat. Quick bites. What did I have there? Quabina was on the Embedded FM podcast. Quabina is one of the two founders of OpenMV, so I think it's worth a listen. Mahmood wrote about connecting the BH1750 sensor to the Raspberry Pi Pico. Useful documentation. Ray McUnderwood, you can read these, right? There's moon phase display. This is actually really cute, cute display. So if you're interested in moon stuff, I'm sure you won't want to miss that one. And I can't remember the author of this one, but there was some power consumption was looked at, using a solar panel to power a Raspberry Pi Pico device, and making sure that he could sort of ensure that it was able to run forever off the solar battery, off the solar power on the battery. That's it for the main topics. Just a couple of things to leave you guys with was the scroll art from Al Swigart, who you might know from Automate the Boring Stuff, which is a really popular Python book. He presented this at PyCon US as a lightning talk, but he'd released it a little earlier. If you guys know Oingo Boingo, if you don't, the main person out of Oingo Boingo was the one who did the Simpsons theme, among other things. But yeah, anyway, this might be loud. The interesting thing was he was showing it's actually not that hard to do some of these things which he calls scroll art, where it's just this is just running in a console and it just spews out stuff, but it's in time to the music. I don't know how well this is working over the Zoom connection, but anyway, I'll let you guys watch this in your own time, but there's some pretty cool stuff that he does. Check it out if you like that kind of thing. And there was also, I haven't been able to find the code for it. It's a very aggressive solver too. I think it's running at 2 times speed as well. Right. You get the idea, right? Pretty cool. And the mid-journey image for the nuts. And that's all I got for you.
G'day everyone, I'm Lachlan. If you go back 5 years to the month, you'll see we gave a presentation on MicroPython 1.13 running on the Propeller2 early prototypes silicon. There's been a fair bit of activity just recently because we're all excited about version 1.13 and in particular the USB support and also the open amp multi-core 1.23. Yeah, we've gone from 1.13
Right.
to 1.23.
Yep.
Hasn't been much in between of use to us, I guess. But yeah, a lot of activity. There's a guy called Allen over in the US who's spending a fair bit of time and has the current version up and running. Brian, who's here tonight over there, he's had that running today and yesterday. So hopefully in the next few days we will get something sort of tested and maybe ready for inclusion in the mainline or the master branch. Damien's created a discussion area over on the Discord for any sort of teething hassles we might have. Yeah, so pretty excited. We'll need to work on how to get multi-core to actually constructively work together, I guess. That's one of the things once we've got open amp in place. Just work out, because we'd love to see MicroPython running on more than one core at the same time. So yeah, any questions about that? Sorry, don't have any props or hardware yet, but yeah.
Maybe the people online, what is the PT?
Yeah, what is the Propeller2?
What's the
Yep.
key features?
So yeah, so key features of the Propeller2, it's got 8 32-bit cores, a lot of instructions. So a RISC architecture has a good sort of egg beta memory model where each core can be accessing a word at a time or in parallel. Runs up to about 350 megahertz, can keep up like streaming out at that rate for all of its 512K of hub memory. Really good A to D converters on every single pin. The guy called Richard Morrison here's put them all through their paces. I think they're good to about 13 bits. They go up and above the rail a little bit, below the rail, so you can have like negative or positive voltages. Got Gertzel hardware for actually syncing up, like if you're trying to measure a sine wave and extract it from a carrier. Really good like that. What else am I missing? You can drive most video sources off like internal pins, so it'll put out a component video across 5 pins or DVI up to well, I don't know, 640/480 or 800 by 600-ish resolutions. VGA though, up to 2000 by 1500. And yeah, you've got 8 cores to play with there, so you can kind of have something impressive happening on some of them, including MicroPython. And then you can do other things independently on the other cores without having to be trying to service interrupts or whatever. So yeah, good fun, potent, and easy to get things up and running fairly quickly. So, but it's got its own quirks as well, and that's for MicroPython would be great. Like once we have that sort of tied together, some of the quirky hardware, I think it'll be really really potent combination. Yeah, and yeah, so yeah, that's about it. Yeah. Any questions from online regarding it, or if there are follow-up questions, just put them in the Discord on MicroPython Discord.